Hello everyone, my name is Saurav Naskar and today I'm going to present a topic on improved user immersion in virtual reality. So first let's go through the table of content. First we'll talk about the motivation behind choosing this topic and the research papers. Second of all, we'll go through the problem statement. Third, we'll discuss the solution overview and all the three papers and their unique ways of providing the solutions and overcoming the problem statement. Fourth, we'll talk about the conclusion and the future work, and also we'll discuss the references as well. So first of all, the motivation. As we know that VR technologies are really new. So in the COVID-19 era, we have seen that all the aspect of daily life move to us online platform to certain degrees, and in that scenario virtual reality they really step up and provided very many innovative solutions. Well, let's take an example of tourism or booking an apartment. So in those scenarios before the COVID era, it used to be like people going there, visiting that place, and actually perceive those things as a natural way, like in an offline manner. But or even like while booking an apartment and stuff, they have to go there and visit that apartment to get a feel of that apartment, how big it is, and how the conditions are, and some and all those factors. But after the COVID-19 pandemic, that physical visitation become really impossible for so many people, and VR in that scenario provide innovative solutions, and they really stepped up and gave that complete presence that were not possible before in a online technology. Like seeing a video or seeing some photos will not give you the feeling, or will not give you the actual dimensions of apartment, or maybe actual feeling of that place. But through the virtual reality technologies, it was achieved to certain degrees, and that's one of the biggest reasons that I chose this topic. So for the problem statement, for VR technologies, every aspect of the VR technology depends on the user and how the user perceives the virtual world, how immersive the user feels in the virtual world. So if for some reason the user doesn't perceive the virtual world as real, or he or she loses the immersion inside the virtual reality, then the whole concept or fundamental of the VR technology falls apart. So the immersion in VR, it is not just related to a single factor or just a few factors. It's actually related to so many factors that are accumulatively contributes to this immersiveness for a user. So let's take an example. For example, like the if a user is like perceiving a virtual reality as real because of the visual aspect, because of how real the scenario, or how real the video, or how real the image quality feels in the virtual environment, then the immersion quality, the immersion for that user would increase. But at the same time, if the interaction methods in the VR application is not up to the mark, or is not properly synchronized, then the user will lose the immersion, and in total the user would lose the immersion even though that the visual aspect is good, right? So in that scenario, the complete aspect of the VR technology, or the complete aspect of that particular application of that VR completely fails, and they fail to deliver their content, they fail to deliver the purpose to feel the purpose of giving the user a real feeling. It's completely gone at that same time. For the solution overview in the proposed literature bodies that I've chose, they have tried to approach this immersion problem in various different ways. So for the first paper, they tried to come up with the best walking interaction techniques that can be used in VR to improve their immersion. For the second paper, they actually generated and implemented a NUI architecture that is better in terms of their performance and better in terms of providing VR content. For the third paper, paper, they actually focused on the visual aspect of a VR technology, and they tried to improve the visual qualities, image qualities of a virtual reality environment, as well as providing a faster approach to process those images. So let's move on to the first paper, that is a study on immersion and VR sickness in walking interaction in immersive virtual reality applications. So for this paper, the authors of the paper chose three very popular interaction methods in virtual reality. That is, first of all, to interact in the virtual reality, the users are previously using some of the most common used techniques. Those are the gamepads. But in this paper, they have chose three different um, feasible, I would say, feasible techniques that can be implemented in VR technologies in current days. So those are like gamepad, a hand interface based motion tracking leap motion technology, and third, a walking simulation using march in place technology. So in this paper, they have actually targeted 20 or more participants, and those participants were in their from age from 20 to 40 years old, and they were trying to get each of the participants to have an interaction in the VR technologies and the VR environment, and they're trying to get a simple questionnaire and simple polls out of their participants and have a bunch of feedback from them. So the first they tried they put the participants in all of those three interaction methods and in VR and in different VR environments, and then they collect some information based on how immersive they feel using those three interaction methods. Then they performed a Wilcoxon test to determine how the difference is, how much the difference is between the satisfaction of various interaction methods. And lastly, they asked the participants some motion sickness based questions that is called the sickness simulation questionnaire. In that questionnaire, they asked different aspect of the VR sickness, which is very common in VR to have a VR sickness, like in depending on the nausea, depending on their desynchronization of oculomotor functions and stuff. So that's why they asked different questions based on how much sickness each participant felt while using those three different interaction methods. So as you can see, these are the three, on the right hand side, these are the three interaction methods. The first one is a gamepad where you control your virtual avatar or your virtual embodiment with the traditional gamepad methods. And the second one is quite interesting, where you actually interact or walk through the virtual environment using your hand gestures, and those hand gestures are recorded or captured by a leap motion device. And the third one is a portable walking simulator that actually simulates your march walking in a same place, and that is actually simulated to the virtual reality technologies, and it actually synchronized with the virtual avatar and represent your movement there. And on the left hand side, you can see that they have used three different environments, so they can conclude for a certainty that the immersiveness is from their interaction method rather than their environmental aspect of it. So they needed to be sure about that the environment doesn't contribute anything for the immersion. This is another overview how those three interactions were designed and implemented. So the first one represent all the technologies that they used, and the second in the B picture B, you can see that the user is controlling their character using the gamepad while they move around the virtual environment using the buttons and using their traditional gamepad method. And for the second approach on this picture C, you can see that the user is controlling the virtual avatar or virtual embodiment of their avatar with the hand gestures while they have some predefined hand gesture to move, to walk, to jump in the virtual environment. And the third one is the walking simulator that the user actually uses. It is actually fitted to the user's leg, and it simulate their march in walking gesture to the virtual reality environment. From the first questionnaire, every participant were asked based on their experience in the virtual environment that each for each interaction method, how immersive each interaction method were. And you can see that in all of those graphs, the green line represents the walking simulator, the red line represents the hand interface leap motion questionnaire graph, and the blue line represents the gamepad questionnaire line. And on the left hand side, you can see those on the left hand side, the A1, A2, and A3, all of those are based on how the user actually um, uh, experience the virtual environment, where the first one they for the left hand side, the first one they used was like a gamepad, then the hand interface, and then the walking simulator. And for the right hand side, they actually implemented it in an opposite way, so they could be very sure that the sequence of that experience doesn't contribute to the user immersion. So on the right hand side, they have put their participants through their walking interface first, then hand interface, and then gamepad interface. So they, after having all those data, they have concluded that the immersion that came from the immersion level and the questionnaire answer were not impacted by the sequence or by the environment itself. It's purely based on the interface they are trying to get, which one is the best. So on the left-hand side table, we can see that in this experiment, they have collected data based on how realistic the user felt in those environments for different interaction methods and for different environments itself. And on the right hand side, you can see the data was collected based on the VR sickness, like let's say nausea or maybe disorientations that they're very common in VR, and they're trying to eliminate those VR sicknesses, trying to find out the best interaction method that actually gives higher immersion and less sickness. So from that questionnaire survey, they have concluded that in terms of immersiveness and in terms of the presence level, the walking simulator provided more immersiveness in virtual reality, followed by the hand interface, and lastly the gamepad. But in terms of VR sickness, the least amount of VR sickness was provided by the interactions or walking simulator in this case, and then followed by the gamepad, and then at last the hand interface. So from all this questionnaire and poll, they have concluded that the walking interaction is best interaction method to implement in a VR situation, and that could provide more immersiveness to a user, as well as omitting or mitigating the VR sickness while a user is consuming a virtual reality environment, or they're inside a virtual reality environment for a long period of time. So for our final paper, it emphasizes on the visual aspect of the virtual environment. So in this paper, the authors try to improve user immersion and presence by using better quality images and as well as better image processing techniques for faster image rendering. So in this paper, what they did was they tried to first increase the sharpness of the image by removing unnecessary noise and information from the image. And then they used multi-scale Radix algorithm to have average weighted image pixels, and then they also enhanced the image pixel using this multi-scale Radix algorithm, which intake a weighted average of the image pixels, and which also incorporates Otsu's algorithm for better, faster image processing techniques. These are some of the equations that were used in this paper. The first one is a Gaussian filter. They use this equation and this formulation to omit unnecessary noise from the image to sharpen the images. And then they use the multiscale readiness algorithm and the equation, which intakes the weighted class average, which can be seen in the third equations. So the weighted class average takes all the neighboring pixels and take the average pixels, and it supplies as an input in the multiscale readiness algorithm, which takes the image and kind of stabilize the image and also stabilize the pixel value, and also that it kind of enhances the pixel value comparing to its neighbor pixels. And by this multiscale readiness, they try it and they achieved better image quality. So here is the flowchart of the whole process proposed in that particular paper. So first they took an input image and then they segmented it via Orso's algorithm. So what the algorithm does was separate the background and the objects, and so it is very efficient and fast in terms of determining the background and the object that is in the foreground of a picture. And after that, they extricated the light source and they actually apply the weighted average method to alter the light source data, as well as like they remove the noise from the object itself, and they merge those two data together and they render a better quality image that is more sharper and that is more enhanced in terms of their quality. Here is the result output, where you can see the image, the input image is on the top, and the normal conventional algorithms after the processing of the image in virtual environment is really dull and really I would say not sharp at all. But you can see with the proposed algorithm, the images that we got after the processing in virtual reality is much crispier and much sharper image, and that leads to a more user immersion. So this is the final result that they have concluded. They have taken five image sets and they compared with the conventional algorithms, and we can see that the proposed method provided more sharper and better image quality, as well as the main factor here is the gap across real and virtual real. So we can see that the gap for the proposed method for the virtual and the real world is very low, and which is desired, because the less the gap would be, the more the immersion a user can achieve in the virtual environment. So in conclusion, I would like to say that I have chosen three research paper that addresses the virtual reality immersion problem a user could face, and they tried to increase the immersion through various ways. The first paper tried to find the best interaction method in virtual reality environment to increase the user immersion, as well as decreasing the virtual reality sickness. The second paper tried to develop and integrate gesture-centric NUI to enhance the user immersion. They also tried to implement a new API that could really benefit from their architecture and that could perform better and that could be more efficient in virtual reality environment, as well as providing a better way to present user interface, as well as they somehow touched a little bit on the user elevation problem and the embodiment problem. And the last paper actually tried to increase the user immersion and present by better image processing techniques and better image rendering techniques, and also minimize the image processing time in virtual reality. And by this, they have achieved much immersive virtual reality content in VR applications. For future work, I can say that we could implement those three proposed methods, and we can just combine those three methods to have a better outcome in virtual reality, as well as we can, after combining all those three, we can again conduct a survey to further improve and enhance the virtual reality application to interact, to perceive the virtual world as real, or we can say to increase the immersion and virtual presence. These are some of the references I have used in this presentations, and thank you very much for watching the presentation.